I have a very special person who is a guest of honor for this afternoon and evening is Rob Penter.
Well, good afternoon. Thanks for having me. Namaste, namaskar. I want to talk about the pace of change in our industry. I want to talk about the importance of geospatial to the world. I want to talk about the importance of geospatial to India. I'm going to talk about what we at Trimble are doing to be a part of that. So before actually I start talking about Trimble, I want to talk about the pace of change and just how fast the world is moving. And so I've been inspired recently by a story from the Olympics. I'm going to start my Olympic story, though, back in 1988. And so in 1988, I was a senior in high school, and I'm from the States. And there was an American runner that year that won the 100-year dash, and this guy's name is Carl Lewis. And some of you might remember Carl Lewis in 1988. He was defending his gold medal. He had won in 1984, and he was defending in 1988. And he ended up winning the 100-meter dash. Now, there's a funny reason he ended up winning, because somebody else got disqualified in that event. But here's the thing. His time was 9.92 seconds, and he won first place and won the gold medal. Okay, now fast forward to this summer. This past summer in Paris, where the Olympics were held. Same 100-meter dash. In the finals, you might remember or know who won first place. It was a guy named Noah Lyles. But I bet you do not remember who was last place in the 100-meter dash. Because why would you remember who was the last place finisher on the 100-meter dash? The guy's name is Oblique Seville. And Oblique is from Jamaica. And by the way, the Prime Minister of Jamaica must be in town, because when we were driving here, he's right here, okay, because his picture was everywhere in town today. His time was 9.91 seconds. He was last place. Remember, Carl Lewis in 1988 had won first place with 9.92. Last place this past summer was 9.91 seconds. The world moves fast. The pace of innovation, the pace of change is relentless. It is moving, and it's moving, and it's moving fast. And I think that is instructive in our world, and is absolutely instructive in the country here in India. Just think about the statistics you were just hearing about how much will change and how much the economy will grow. So I want to talk about Trimble for a few minutes. Talk about Trimble as a geospatial company. It was founded in 1978 by Charlie Trimble. We work in industries such as engineering and construction, so that's construction, geospatial technologies, transportation, and agriculture. And so when I think about the why of Trimble, I say feed the world, move the world, build the world. So let's talk about that. If we look at the construction industry, the data tells us in construction that 80% of projects are late and 40% of projects are over budget. It's a staggering statistic when you think about that. Think about all the infrastructure that's being put into this country, and the data tells us 80% of these projects will be late and 40% over budget. The data also tells us that over 80% of the lifetime cost of a built asset happens after it is delivered. So the maintenance and operations ongoing of a project. The data in the world also tells us that to feed a world's growing population, we're going to need 69% more calories by the year 2050. How are we going to do that? We need technology to do that. And if we go back to that construction example and we think about the statistics around the inefficiencies and the lack of productivity, it equals over 1.6 trillion US dollars, and that's the size of the economy of Canada. In the world of transportation, globally there are driver shortages. There's not enough drivers of all these trucks. But what we know is that if we could save drivers just 20 minutes a day, we could make their work 20 minutes more efficient. It could be through that routing and optimization networks. We don't have a driver shortage. And I know how important transportation is going to be here in the Indian economy. You have an opportunity, I think, to cut those logistics costs by half in order to get more of the goods out of the country for export. There's also a need to make the work be done greener. And when we look at the technologies that we deploy at Trimble, there's hundreds of millions of metric tons that could be eliminated, not put into the atmosphere every year. And that's the equivalent of Spain's emissions on an annual basis. So this work, there's a real imperative for the work to be done. We can help this work be done better, faster, safer, cheaper, and greener. And so Trimble technology is connecting work in the physical and the digital worlds. It's connecting work in the office, in the field. It's connecting the hardware and the software of Trimble. And that technology stack at Trimble can be represented, to me, at the intersection of three words. It's the where, it's the what, and it's the why. Where represents positioning and sensing technologies. It's the spatial intelligence. At Trimble, we don't think about being close enough. We think about precise position. A surveyor fundamentally creates a digital model of the physical Earth. They create the geometry, that X, Y, Z coordinate. It's a basis of a model. Well, what is that model used for? At the point that you've created the where, you eventually are asking yourself about the what, because the what represents what are you going to do with that position. The what looks like adding attributes and context to that geometry. It looks like creating a model-based workflow. It looks like doing design and simulation analysis around a position. If you have the where and the what, and you're in the year 2024, you're asking about data and you're asking about AI, you're asking about the why. This is the analytics. This is the higher order problems that our customers are trying to solve. It's this intersection of where, what, and why. At the intersection of the physical and the digital worlds. And it's doing so in a connected, inside a connected ecosystem. That strategy today has taken Trimble to become almost a $4 billion turnover company with over 12,000 people in the company, putting over $600 million a year US dollars back into research and development. So this is Trimble on a global basis. We're doing business in almost 150 countries. One of those, of course, is India. We've been doing commercial business in India for over 40 years. We've been doing development work in India for over 20 years. We've got 6 offices in the country. Actually, our largest engineering center is in Chennai, where we have over 1,400 people today. So when we talk about Make in India, and I've been in meetings the last couple of days, almost every meeting is talking about this. So it is very clear how important this is to the country at the moment. We are India. We are making in India. And to me, making in India is more than just about the team that we have. It's also what we put back into the communities. And so we think a lot about not only our own team, which gets recognized as being the best global company culture, being a top workplace for innovators. We also think about the corporate social responsibility. We think we have a responsibility to put back into our communities. So let's talk a little bit more about what we're actually doing. So that technology stack at the intersection of where, what, and why applied to industries. Trimble has helped put in a continuous operating reference station. It's called a CORS network. There's over 1,000 receivers that have put in placed in fixed positions. You need this positional accuracy. Remember, at Trimble, we think about centimeters, where centimeters matter. This becomes a basis for cadastral surveying when you have this highly accurate position, and you have the cadastral surveying to help with the land management. And I know my friend from the World Bank is here. You're doing some work as well with the country. This matters to have this coordinate system. These same coordinate systems will be used to assess deformation monitoring when you have land movement, if you have earthquakes. You need to understand that. If you're putting in a high-speed rail network, and you are, when you put in a high-speed rail network, centimeters matter. In fact, millimeters matter to operate at a very high accuracy. If we look at additional work that we do in the country, where the where meets the why, is you have Trimble technology being used in utility projects, both water utilities as well as electric utilities. The same technology is used to build the rail. This is when you're putting in the rail, like the installation of the rail, but also for the maintenance of the rail. Because again, that rail can move, and so you need to be able to precisely measure and monitor the rail so that you can maintain it properly. You build a lot of tunnels in your infrastructure. To do the precise tunnel boring work and to make sure that the walls aren't collapsing in the tunnels, you need to use an array of technology, from scanning technology to positioning technology, to make sure the work is done safely and to make sure that it's done on time and on budget. This is an example of putting Trimble positioning technology and automating construction equipment on the top left. It's called machine control and guidance. You have high precision GPS or GNSS. We control the hydraulics of the equipment. We have the digital design model from the engineering design model for a linear alignment. And I believe this was from Mumbai to Delhi expressway, where it's on the construction equipment. We take the design model and we turn it into a machine model. We effectively turn that construction equipment into a 3D printer. And what happens is you move the dirt right the first time when you're actually building to the design. And you can generate almost 40% productivity improvement through the use of technology. And you have a lot of work to do in India to build out the road. Don't you want it done fast and of high quality? This is what the technology enables. Up on the border, you use the same technology for snow removal, and I know some military officials are here. So on the across the border, when you have a lot of snow on the road, you don't actually know when you're about to go off the road. You need that high accuracy position to tell you where you are to be able to do that and automate that snow removal. Trimble technology is used to build out breakwaters. What you're putting in this country in terms of the ports is almost staggering, the amount of work that you're doing, and it ties into the export economy that you're continuing to build. You use the same technology on the bridge here. This is the highest arch bridge in the world that's been built in India. It's a rail bridge project. You have to use technology to do that. Statue of Unity was designed with some Trimble technology. It uses our positioning technology to manage the monitoring. So it's called deformation if it's actually moving. You need to be able to know that. That's the Chennai Airport on the bottom right, and the new Parliament building on the top right, using Trimble hardware and software to both do the modeling as well as to ensure the quality of the work that's being installed. So there's an impressive amount of technology that's already being used, and we believe it's necessary, and we believe that the geospatial as an industry serves as the foundation for the digital infrastructure and the vision of self-reliance that you have. So some of the statistics I have, 35,000 kilometers of highway to be built in the next 5 years. The amount of office space you'll build as you continue to urbanize and grow the population, tens of millions of square feet will be built every year. The infrastructure budget alone is almost 4% of your GDP. And then we know some of the data around the foreign direct investment that comes here, part of the make in India. Now, Sanjay also invited me to talk about a perspective we have at Trimble of how to turn a vision into impact, and how I see an opportunity for India to benefit, and some things for us to consider together. So call it a Trimble perspective, call it my perspective. And I'll give you 4 things that I think about. I'll start on the top right. So the Make in India initiative, very easy to understand the policy. I also think there's an opportunity to reframe how we think about this. If you think about this phone that I'm holding, how much of the value in this phone is in the physical versus the embedded software that runs it? The car I have at home, it's a software-defined vehicle. It's the software that powers that vehicle. I submit that less and less of the value is in the physical, that the real value is in the software. And in the case when that software is being made in country, I would argue that Make in India is better served and understood through the software than the physical product. Now, both can be done, but I think there's something to put into a bigger context. So one of the things I worry about is that as a multinational business is we can make the supply chains extraordinarily expensive by doing this. If every country in the world were to say it needs to be made locally, that goes against the interest of being able to keep the prices down so that we can bring the technology adoption up. So I think it's something to think about. At the bottom right, I think about the intersection of government, business, and academia. And I think about having just come from National Highway, but I also think when I think about that, I think there's a partnership to be had in terms of how we educate and promote the use of geospatial technology. I think it takes everybody in the room and everybody in the industry to work on this together. That's producing case studies. And I think the case studies on the bottom left to me are important. Is it's easy to have a vision. Kind of talk is cheap. Action is better. Show me, like show the results and be able to share them. Share those proof points. To me, that's very important, as when we as an industry can promote the case studies of success from the adoption of the technology. And on the top right, or the top left, if you've done everything else I've talked about, then I think it's reasonable that we look and say, how do we specify, not only promote, but actually specify that technology is used. So you go back to that 35,000 kilometers of road to be put in the next 5 years. Through the use of that technology I was showing, you can actually put in more kilometers every day of road when you're using technology like we have at Trimble and like others have in the industry. I say with pride, I think that's worth specifying that it should be used in your construction. It's done, it makes that construction almost 40% cheaper. I think that's a reasonable ask as an industry that we have anywhere where I presume everybody in the room, almost everybody in the room is a taxpayer. Don't you want your taxes to be used efficiently and effectively? I know I do. And it goes further even than just the control technology. It's called compaction technology. One of the things that we know, and we've seen it here in India as well, is those big rollers. Those are what are called compactors. They're compacting the soil before you actually put the sub material, the substrate, and then the asphalt down. Poor compaction is when you get the roads that do this, or that fall apart after they've been built. When you specify technology, you can actually perform quality checks that the compaction's being done right the first time, ensuring the quality build. At the same time, we're ensuring that our roads are built better and faster. And so, I'd leave you with the thought, and when I think about this, I know this has been part of the government policy one earth, one family, one future. And if I can say it right, Vasudhaiva Kutumbakam. One earth, one family, one future. We think about one Trimble, one India, one future. Dhanyavad, shukriya.
Thank you. I have a question to you, which is really I wanted to ask. So, what do you think that Trimble would actually do more, and what do you expect from the government or Indian market to do more in India?
Well, I think my expectation is that there'll be more government mandates, particularly for government work on made in India products or made in India technology. So I would expect that there'll be, I would say we already are making the software.
Yeah.
So that's a fact that we already do that in India. In terms of the physical product, I think what we'll have to do is be selective about what we can actually afford to be able to make in country. And a good amount of the examples I was showing, I think those are products that could make sense for us as Trimble to produce locally.
So to produce locally, and specifically, are you looking at any specific, expectations from the government of India in terms of any kind of policy reforms or any kind of, ease of doing business? Is there something which kind of restricts?
Any multinational business is going to appreciate when there's clear rule of law, when there's clear movement, a free trade. So I call it frictionless or near frictionless movement of goods is necessary as a business. But I'm more interested, I think, in how government can be part of sponsoring specification of the technology and more promotion of the technology. So, I don't want any special favors. I want to see government and business working together to promote the use of technology.
So thank you very much for your leadership and your commitment to Trimble for India. Thank you. Thank you.